Severe weather pretty much all over the place, including the southern plains, Midwest, Ohio Valley, and a bit of rain in the Pacific Northwest and California, Arizona. Good morning, I'm meteorologist Pew. Today is September 21st, 2025. So starting with severe weather, we have a slight risk, or a 2 out of 5, specifically in the southern plains from Oklahoma to Texas. But we also have a marginal risk going from the southern plains all the way to the Midwest, Great Lakes region, and the Ohio Valley. And what this entails is that we have a 5% chance in all these risk areas to see winds up to 60 miles per hour and large hail, but only in places in the Midwest, Ozarks, and the southern plains, where the southern plains have a 15% chance. But in terms of flash flooding, we have a slight risk in the borders of Kansas, Missouri, Oklahoma, and Arkansas, with a marginal risk going from the southern plains to southern Illinois, but also in California to Arizona. So time frame, starting with the southern plains, as you guys already have an MCV, or a mesoscale convective vortex, or basically a localized circulation that's causing some showers this morning into the afternoon. And we're going to see more intense storms start popping up around 4 to 5 p.m. Central Time. This also includes the Ozarks and Ohio. And for Illinois, Indiana specifically, we're going to see remnants of those storms that are going to travel from Missouri and then travel northeastward. So for places like Illinois, we're going to see something around 6 to 7 p.m. Central Time. And you can expect a lot of these storms to travel overnight as well. For the upper Midwest, Minnesota specifically, it looks like models are kind of suggesting that something's going to happen around 7 to 8 p.m. Central Time. Now for Southern California, Arizona, it looks like things are going to start around 2 p.m. Mountain Time, or that's 1 p.m. Pacific Time. But also the same thing can be said for the Northern Rockies as well, including Idaho and Montana, where both these areas are going to see isolated to scattered showers to thunderstorms. Now why does this all happen? If we look at 500 millibars or midway through the troposphere, we have shortwave troughs pretty much everywhere. We have one in the southern plains, we have another one in the Great Lakes region, we have another one in the Minnesota area, and we have one in the Pacific Northwest and also in Southern California. And what all these troughs have in common is we have pretty decent shear, which is going to tilt those updrafts and prolong the storms, but also some of them have a lot of vorticity or spin, which is going to help with those upward motions. And speaking of vorticity, there's two vorticity maximums that I want to look at, or concentrations of spin, in Kansas and Oklahoma. And this is actually one of the main reasons why we have an MCV in Oklahoma, or that localized circulation. And so when you have a vorticity maximum headed into an area, that area specifically will have a positive vorticity advection. And we call that PVA, and that's going to help with the upward motions in these areas to produce those thunderstorms. Now looking at the surface, we still have that high pressure in the south in the Gulf area, and that's pulling in a lot of Gulf moisture into the southern plains and all the way up to the Midwest. And for the southern plains, with that warm air advection from the Gulf, we're going to see dew points up to the 70s, whereas in the Midwest, we're seeing around like the 60s. And I also want to look at satellite imagery, because we have pockets of clear skies or clouds breaking up, and any diurnal heating or sun is going to help with that surface heating and increase the instability at the surface. And that's why we have